Problem 2.9, find the total weight of a 10 cubic foot tank of oxygen if the oxygen is pressurized to 500 psi. The tank itself weighs 150 pounds force and the temperature is 70 degrees Fahrenheit. In my situation diagram, I noted that the weight of the tank is 150 pounds force and that the volume is 10 cubic feet. Notice here that I converted pressure and temperature to consistent units. In particular, I multiplied pounds force per square inch by 144 to convert to pounds force per square foot. Also, I added 460 to the temperature in Fahrenheit to convert to Rankine. The goal is the total weight. This includes the weight of the tank plus the weight of the oxygen.
When I generated ideas, I discovered this problem could be solved with three ideas. First, the total weight is the weight of the metal plus the weight of the oxygen. Second, weight and mass can be related with Newton's law of universal gravitation. Third, the mass of oxygen can be calculated with the ideal gas law. I'll demonstrate the process on the whiteboard.
Start with an equation that has your goal in it. Since the goal is the total weight, one equation is the weight of the oxygen plus the weight of the tank. In looking at this equation, there's our goal. Excellent. We know the weight of the tank. That is specified as 150 pounds. If we can find the weight of the oxygen, we are done. So let's use Newton's law of universal gravitation, and the weight of the oxygen will equal the mass of the oxygen times the gravitational constant g. There's our goal. We know that. Now if we can find the mass of the oxygen, we are done with the problem. So if we select the ideal gas law, we know that the pressure of oxygen in the tank times the volume of the tank is equal to the mass of the oxygen in the tank times the gas constant, 4O2, the specific gas constant, times the temperature of the O2. We can look this up. This is known. The volume is given. The pressure in the tank is given. This is our goal. Excellent. Now we're done. Plan-wise, we can use this equation first to calculate the mass. Once we use this equation to calculate the mass, we can then calculate the weight with this equation. Then we can take the weight, put it in here, and calculate the weight total. And it's even easier. We can actually skip this step. I'll show you a trick here. So step one of our plan is to calculate mass with the ideal gas law. Step two is calculate the weight total, and we'll be done with the problem.
As shown, execution of the plan has two steps. Step one is calculate the mass of the oxygen using the ideal gas law. Notice two things. First, I use the mass form of the ideal gas law because that's the easiest thing. And number two, the unit calculations are straightforward because I used consistent units. The answer is 0.87 slugs, which I immediately converted to 28.1 pound mass by multiplying by 32.2, which is a conversion ratio. Then I immediately noted that if the mass is 28.1 pounds mass, then the weight of the oxygen will be 28.1 pound force. So now that I know the weight of the oxygen, I add this to the weight of the tank, and the total weight is 178 pounds force. A very useful fact is that a mass on Earth of any magnitude will have a weight of exactly the same magnitude. For example, a mass of 10 pounds mass will have a weight of 10 pounds force. Let me show you why this is. To relate a mass to weight, we can use W equals mg. 10 pounds mass times the gravitational constant, 32.2 feet per second squared. Units don't work, so I multiply by the appropriate conversion ratio. Now I cancel all the units out, and I also note that the number 32.2 cancels out, and I'm left with a weight of exactly 10 pounds force. The reason for this, in the traditional system, a force of 1 pound force is exactly equal to the amount of force that will accelerate a mass of 1 pound at a rate of 32.2 feet per second squared. This is simply a definition. Note that consistent units greatly simplify our life. They make the calculations much simpler. When you're using SI units, be sure and use mass in kilograms, length in meters, force in newtons, pressure in pascals, etc. Similarly, in the traditional system, use mass in slugs, length in feet, force in pounds force, pressure in pounds force per square foot, etc. This concludes the solution of problem 2.9. Remember that the key to becoming a really good engineer is to practice fundamentals until they become your way of doing things.